Now that we understand light, and have talked a little bit about matter and how matter and light interact, let's start looking at how it is that we can learn from light. As we look at light, one of the things that actually gives us the most information is the spectrum of light. If you remember back, the spectrum is where we take the light and we spread it out into all of its different colors. Well, there are 3 different types of spectrum. The first one we're going to mention is the continuous spectrum. The continuous spectrum is the full perfect rainbow, where it goes from red through all of the colors out to violet with no breaks or skips or jumps or anything. An emission spectrum is only a few lines of bright color. All of the other colors are missing. This is actually the type of spectrum that you're going to get from a halogen or a fluorescent light bulb. The last is the absorption spectrum. The absorption spectrum has most of the rainbow, but it's missing a few lines of color. Now, each of these is formed in a slightly different way and is therefore going to give us a little bit different information. Let's start with the emission spectrum. The emission spectrum actually goes back to how it is that energy is stored in atoms. If you remember back, electrons are not just allowed to be wherever they want inside the atom. They're only allowed at certain special locations, and therefore only contain or can only hold very specific amounts of energy. We refer to these different locations and the amounts of energy as the energy levels. So in this, we're looking at an energy level diagram. Down here on the bottom, we have the ground state where the electron has no energy. This is level number 1. Then as we go up in energy, we have level 2 and level 3 and so on. So let's say we have an electron that is going to fall from high energy down to low energy. For it to be able to do that, it must give off the energy, and the most likely way for it to give off that energy is as light. So, for example, let's say we have an electron here on energy level 3, and it's going to fall down to energy level 2. For it to be able to do that, it has to give off the exact right amount of energy. Now, this transition is relatively small, and because it's relatively small, the electron doesn't have to give off a lot of energy, and the amount of energy it gives off is going to correspond to red light. So as the electron falls from here down to there, it gives off red light. Now let's say we have an electron up here on energy level 4, and it transitions down to energy level 2. As it does that, this is now a much larger transition, which means it's going to have to give off a lot more energy. In this case, the energy it gives off is going to correspond to kind of a blue-green color. Okay, so more energy, shorter wavelength, this is going to be blue-green. Here at energy level 5, as it transitions down to level 2, this is a much larger transition, which means it's going to give off blue light, and then from 6 down to 2 is an even larger transition. It's going to give off purple light. So the larger the transition, the higher the energy. Now notice that this electron in the atom is not going to be able to produce yellow or orange light. For it to produce yellow or orange, the electron would have to be somewhere in this region and fall down to energy level 2. But the electron is not allowed to be in this region. So this atom will produce red, blue-green, blue, and violet light, and that's it. It's not going to be able to give off any other colors, because of the way that the electron is transitioning. So here we have the emission spectrum for a whole bunch of different elements. So the one that we were just looking at is hydrogen, with the red, the kind of blue-green, the blue, and the violet. Okay, this is the emission spectrum of hydrogen. Now compare that to the emission spectrum of helium. Notice that the bright lines are not in the exact same places. They have shifted. Okay, in fact, compare any of these and you'll see that all of the bright lines are in different locations. What this means is we can actually use the emission spectrum to determine what is there. Only one type of element is going to be able to give us a specific pattern. So, for example, if we see this pattern it being given off by a star or other object, then we know that helium has to be present. If we see this pattern here, then we know that water vapor has to be present, and so on. We use the pattern of the emission spectrum as a fingerprint to help us identify what elements are there. Now, the way that an emission spectrum is actually produced is from an energetic gas. Something has happened to this gas to cause it to become excited. This could be that the gas is hot in the case of things like the outer atmosphere of a star. It could be that this stuff has had a lot of collisions or has been energized. So, for example, in a fluorescent bulb, we have electricity running through the gas, which is causing the electrons to jump up to higher energy level. And so something has happened with this cloud of gas that has caused it to become energized. Okay, then, as the electrons fall from high energy down to low energy, they produce the emission spectrum. Related to the emission spectrum is the absorption spectrum. The absorption spectrum is the same idea, but in reverse. Instead of having the electrons go from high to low energy, in an absorption spectrum, the electron absorbs, which is why it's absorption spectrum, absorbs energy and transitions up. So, as light comes in, the electrons will absorb the colors or energies of light that they're able to and transition up. So, as light comes in, the electron here can absorb red light, it can absorb the blue-green, it can absorb blue, or it can absorb purple or violet. Okay, however, this electron will not be able to absorb orange or yellow or green, so those colors are going to be able to pass right through. Now, once that color of light has been absorbed, that energy is no longer available for us to see, so that produces a dark line. So the way an absorption spectrum is going to be produced is we have some sort of continuous spectrum being produced. We'll mention in a little bit that the most common source of continuous spectrum is a hot light source. And so it is glowing simply because it is hot. This continuous spectrum then passes through a cool cloud of gas. The cool cloud has electrons in low energy levels. As the light hits those electrons, they absorb the colors and energies of light that they're able to and transition up. But because that light has now been absorbed, when we look through the cloud, we are now missing certain lines of color. Okay, so this is how an absorption spectrum is produced. Okay, now in this diagram, notice this top one, we've got an emission spectrum, and in the bottom we've got an absorption spectrum. In this case, we're looking at the emission and absorption of hydrogen. Now notice that if we were to add the emission and the absorption spectrum together, we would end up with a continuous spectrum. What this means is that you can actually, from either the emission or the absorption spectrum, look at the pattern to determine what elements are actually there. For the emission spectrum, we look at what bright lines occur and find the pattern, and that tells us the element. For an absorption spectrum, we look at what lines are missing and look at the pattern of missing lines, and that tells us what elements are there. Okay, but in this way, we're actually able to determine the composition of a star or cloud or something like that. All right, here is our third clicker question. How is an emission spectrum formed? A, an object begins to glow simply because it is hot. B, the electrons in a glass absorb certain wavelengths, allowing them to jump from a low energy level to a higher energy level. Or C, the electrons in an excited gas fall from a high energy level to a lower energy level, producing light of certain wavelengths. Go ahead and think about it, and we'll discuss in just a bit. All right, so how do we form an emission spectrum? An emission spectrum occurs when we have electrons that start out in high energy level and then give off that energy as they fall to a lower energy level. So the correct answer is C.